Hey guys, today we're going to do Unit 8, Lesson 4, which is all function operations, ways that we can put functions together and work with them. So the first thing that we're going to do is some practice on evaluating a function for just a regular number, which you did in Math 1. And then we're also going to be doing all of these operations with functions, okay? This is the function notation. And so notice if I'm going to add two functions together, you can write it like this and like this. So it is important to be able to understand what these look like in both forms. So we're going to add, subtract, multiply, and divide our functions. When we divide, we do need to understand that that there's a restriction in the domain if we're going to graph it, because whenever you divide two numbers, you cannot divide by 0. You get an undefined number or value for that as an answer. And so we just need to be sure that our denominator function does not equal 0. And then finally, composition of functions is when you take one function and you put it inside of another function. So let's go ahead and get started. For all of our examples today, we're going to be referring to f of x, g of x, and h of x, okay? Now, whenever we finish that up, we're going to end up with something brand new. So let me grab some pens, okay? So we're going to take the function f of x and evaluate it for the number 5. And if you recall, what that means is we're going to take the 5 and plug it in for x everywhere there is an x in the function. So let's go ahead and do that. So f of x looks like this, where you see x's everywhere. F of 5, let me do a little bit of color coding. F of 5 is going to equal 3 parentheses squared plus 4 parentheses minus 1. And we're going to go ahead and plug in a 5 everywhere that we had, where we originally had an x value. And now we're going to start to simplify. So remember your order of operations. 5 squared is 25. 25 times 3 is 75. Plus 4 times 5 is 20 minus 1. So I have 75 and 20 is 95 minus 1 is 94. So the way that I write my answer is f of 5 equals 94, where 5 is the input, and then what I get out as a final value, this is my output. Okay, so we've just evaluated the function f of x for 5. Let's do the same thing with g of x, except I'm going to evaluate this function with what looks like another function, okay? So I am again going to do g, but everywhere there's an x, I'm going to replace it with 1/2 x plus 1. So 1/2 x plus 1. Oh, and I meant to color code that. So g of x is 8x plus 5. Okay, and again, this is where I did the substitution. Okay, all right, and so now I'm ready to just simplify this. So 8 times 1/2 x is 4x. 8 times positive 1 is 8. And now I'm going to bring down this 5. And so I end up with g of 1/2 x plus 1 equals 4x plus 13. And that's it. That's my final answer. Again, this is my input. This is my output, even though it's not a single number value. So that is evaluating functions with a number and with a binomial. Let's take a look at adding functions. So we're going to do f of x plus h of x. Okay, so f of x is 3x squared plus 4x minus 1 plus my h of x is negative 4x squared. So what I'm going to end up having to do here is just combine any like terms that I have. So 3x squared minus 4x squared is negative 1x squared. And then there's nothing else to add to any of these other terms. So 4x minus 1. Okay, and so that is adding f plus h of x. And that's the final answer. Let's do that again with f of x and g of x. Okay, so f of x, again, is 3x squared plus 4x minus 1. Here's my plus sign in the middle. G of x is 8x plus 5. And so I'm going to combine any like terms that I have to get my f plus g of x. And so here's what it will equal. There's nothing to combine the 3x squared with. 4x plus 8x is 12x. And then negative 1 plus 5 is 4. And that's my final answer. Okay, so far, hopefully this is feeling kind of simple and easy for you. Let's go ahead and move on to subtraction. With subtraction, again, we always need to be a little more careful. If you want to put parentheses in when you're adding, you can, but you don't have to when you're adding. It's when you're subtracting that those parentheses are super important. Okay, so we're going to repeat f of x and g of x, but this time we're going to subtract them. So 3x squared plus 4x minus 1 minus g of x, and this time I need to put that in parentheses, 8x plus 5. And so the parentheses are so important because you need to be sure that you distribute that negative 1 to both of your parts of your binomial. So I get negative 8x minus 5 when I do that distributing. And so now let's combine this with this to get f minus g of x. So 3x squared, 4x minus 8x is negative 4x, and negative 1 and negative 5 is negative 6. And that's my final answer. Okay, we're going to do another one. Let's do h of x minus f of x. So h of x is negative 4x squared minus this parenthesis, and I'm going to put the f of x in here, 3x squared plus 4x minus 1. I'm going to go ahead and distribute my negative to everything, so I get negative 3x squared, negative 1 times 4x, negative 1 times negative 1. Okay, and now write this notation. Okay, so now I'm ready to combine my like terms. Negative 4x and negative 3x squares is negative 7x squared. And then there's nothing else to combine with these last two terms. So I just bring them down. Whoops, can you see that? Okay, and so that's it. That is evaluating a function, adding functions, and subtracting functions. Let's move on to what it looks like when we're multiplying them. Okay, so we are going to multiply h of x times g of x. So let me bring these down. H of x is negative 4x squared times, I'm going to go ahead and use a parenthesis. G of x is 8x plus 5. Again, just in case you're forgetting how I know what these are, I am still using these same functions, okay, from the first page of our notes. All right, so I'm just going to go ahead and distribute these, and that's going to give me f times g, oh, that's an h, sorry, of x. So negative 4x squared times 8x is negative 32x cubed. And then negative 4x squared times 5 is negative 20x squared. And that's it. I'm all done. Okay. Let's do g of x and f of x now. G of x is a binomial, so I'm going to put it in a parenthesis as well. 8x plus 5 times 3x squared plus 4x minus 1. Okay, so I'm going to go ahead and I need to distribute the 8x to all three of these parts. Okay, so I'm going to get 8x times 3x squared is 24x cubed. 8x and 4x is 32x squared. And 8x and negative 1. Okay, now I am going to go ahead and distribute the 5. So 5 and 3x squared, and I'm going to line it up. So it's going to be an x squared. It'll be 15x squared. So I'm going to line it up with the like terms that I can combine it with next, okay? 5 times 4x is 20x, and 5 times negative 1 is just negative 5. So here's what I'm going to get for my function. G times f of x is going to equal 24x cubed. Combine 32 and 15, and I'll get 47, and that's positive, x squared. 20x and negative 8x will give me 12x, and then bring down the minus 5. And that's it. I am done with that example. Okay, let's take a look at some dividing. Okay? So I'm going to start with f of x on top divided by h of x. So let's see how we do this. So f of x is, again, 3x squared plus 4x minus 1. Now we are using the same functions over and over and over, but these functions can be whatever a problem says that they are, okay? It doesn't always have to be these three functions. H of x is negative 4x squared. Okay, so here's how we're going to have to do this. We need to break this up. So the negative 4x squared is the denominator for everything. So to make this easy, 3x squared divided by negative 4x squared. Okay, positive 4x divided by negative 4x squared, and then negative 1 divided by negative 4x squared. And so what I'm going to do is I'm going to reduce each one of these and then put them all back together, okay? So this way I end up having 3 terms, but I'm going to simplify each one independently, okay? So we do need to remember our exponent rules. Just like up here when we did our multiplication, x squared times x got me to my x cubed. So, so maybe I should add the exponent rule is x to the a times x to the b equals a to the x plus b. That's when we're adding our exponents. And so when we're dividing, it should look like this. X to the a over x to the b gives me x to the a minus b. We need to subtract these exponents. I'm going to zoom in a little. Okay, so x squared and x squared. So 2 minus 2 is 0. So remember, that just leaves me with the value of 1. Anything divided by itself is 1. So I have negative 3/4. That's one of my terms. Okay, now let's simplify the next term. 4 divided by 4 is 1, and I have a positive and a negative. So the value will be negative 1. And now I have an x squared on bottom and an x to the first power on top. So the value of the larger exponent is on bottom. So I'm going to do 2 minus 1, and then I've simplified that part, okay? And finally, I have negative 1 divided by negative 4. Well, that's going to give me a positive 1. The x squared is on bottom, and it can't really go anywhere. So this is my function. I am going to go ahead and put this back together the way that it should be. So let's do 1 over x squared, and that's positive, minus 1 over x minus 3/4. So this does get a little messy. However, I just break it up and solve it as 3 different monomials and put it back together at the end. Okay? All right, what about we're going to divide 2 functions and evaluate them both. Everywhere there's an x, we're going to replace it with a 2. So let's go ahead and put this on top. The function f goes on top. 3x squared plus 4x minus 1 over the g function, which is 8x plus 5. And so they want me to plug in a 2. So in this case, I'm just going to simply be evaluating this, and my answer should come out to be a single number. So 2 squared is 4. 4 times 3 is 12, plus 4 times 2 minus 1 over 8 times 2 is 16. Bring over the plus 5. Okay, 12 plus 8 is 20, minus 1 is 19, and 16 plus 5 gives me 21. So f of g of 2 equals 19 over 21. Okay, and that's my final answer. That's my final answer. Trying to make sure that we can all see it on the screen. All right, let's talk about composing functions. So when we compose functions, we always take whatever's on the inside and plug it into the function that's on the outside using our function notation. So here's what we're going to do. On the outside, I have the f function. So I'm going to write the f function. Let's see. 3x squared plus 4x minus 1. So that's f of x. Okay. Now I'm going to take h of x and plug it in everywhere. H of x is negative 4x squared. Negative 4x squared. Yeah, I used the right one. So h of x is the function that goes into the parentheses this time. Let me zoom in. Okay, and so now I'm ready to simplify this. So let's start with our parentheses. Negative 4 to the x squared squared. So let me write our exponent rule again here. I'll put it at the bottom. X to the a to the b equals x to the a times b. So we're going to multiply our exponents. All right. So in this case, I will have x to the 4th power, and a negative 4 squared is going to give me 16. And then bring down the 3. So a lot of students make the mistake of just doing 3 times negative 4 and getting negative 12. But you want to make sure if there's exponents here that you square that number inside the parentheses first and then multiply it by the outside number. Okay? So 3 times 16, let's see. 3 times 6 is 18. 3 times 1, carry the 1. So I got 48x to the 4th power for my first term. Now let's do the second term. There's no exponent out here. So I'm just going to do 4 times negative 4 and get negative 16 and carry the x squared down. And there's no simplifying to do either. So negative 16x squared. And there's no simplifying to do with this negative 1. So this is my result when I composed these two functions. I put the h of x function inside the f of x function everywhere there was an x. Let's do that again. Okay, so this time we're going to take the h of x function. So let's write h of x equals, and it is negative 4x squared. That's my h function. Now, inside the h function, I need to put the g of x function. 8x plus 5. Okay, and now I'm ready to simplify this. So let's square this first. This is a binomial, so here's what we'll get. We're going to get 8x plus 5 times 8x plus 5. Remember, that's what that means. And so let's do our distributive property. That will be 64x squared plus 40x plus 40x is 80x plus 25. And then don't forget to continue to bring down this negative 4. Okay, So now my very last step is to distribute this -4 everywhere. I'm going to use my calculator and cheat just a little bit. 64 times 4 is a negative 256x squared. 80 times 4 is, and that's a negative, so distribute that as well, 320x, and then 4 times 25 is 100. And that is my final answer. Okay, when I put the g of x, which was a binomial, inside the h of x. So h of g of x. Okay. Awesome job, guys. I know this can get a little tedious. Let's look at, this is our other way of writing this function notation. So just kind of take a look at what's happening, okay? So what we're going to do is we are going to take, we always want to work from from right back to left. So we're going to take the -1 and plug it into the g function. And then we're going to take all of that and plug it into the f function. Okay, so let's see how this is going to look. I'm going to go ahead and write out the f function, f, which was what? 3x squared plus 4x minus 1. So that's the f function. Now I'm going to put the g function inside these parentheses. 8x plus 5, 8x plus 5. Okay, and now what do I put inside these parentheses? I put that -1 inside there. Okay, so this is the g function, and I put the -1 inside the g function. And then I took the g function with the -1 and I put it inside the f function. And now I just have all these numbers that I can work with, okay? So 8 times -1 is -8. -8 plus 5 is -3. Okay, so let me just, -3. And then -3 squared is 9. And 9 times 3 is 27. All right, let's work with my next term. 8 times -1 is -8, plus 5 is -3. 4 times -3 is -12. And then I can just bring down this -1 because there was nothing to simplify there. All right, so now I'm going to do 27 minus 13, really. Okay, 27 minus 13 is going to give me 14. So my final answer here is 14. 14. All right, let's do our last example for today before we start our practice. So I'm going to do the same thing. I'm going to take the h function and put a 2 inside of it, okay? And then I'm going to take that and put it inside the g function. So my g of x function is 8x plus 5. Okay, now I'm going to do the h function, which is -4x squared. And then inside that, I put the 2. Okay. And now I can just simplify. So 2 squared is 4. 4 times negative 4 is negative 16. Let me cheat again. 16 times 8 is 128, and it's negative. And then I'm going to go ahead and add the 5, which is going to give me negative 123. Okay, so that is composition of functions and evaluating a number at the same time, or evaluating them for a number. Now, here is something that you could also do if you're not as comfortable with plugging in and plugging in again. You could also complete it this way and then just simply plug in the number afterwards. So let me kind of show you how we could have done that with our g of h. So I could, hopefully I have enough room here. I'm going to take the g function, which is 8 parenthesis plus 5, and I'm just going to put in the h function, negative 4x squared. And now I'm going to simplify this. So that's going to give me a negative 32x squared plus 5. And now that that's simplified all the way, now you could take your 2 and plug it in there. Okay? And so 2 squared is 4. 2 squared is 4. 4 times negative 32, just to double check it, is negative 128. And then, of course, you still have to add the 5. Okay, so that's sort of just an alternative. If you just want to do the composition of the function and evaluate it last, you can do that too. You'll still get to the same answer. All right. Well, that's it for today, guys.